Alright, Mr. Keller, this is quiz number 43 for David Engell. And starting with number 1, the way you do it, simply RF sine theta. Since the bar can be localized around its center, you take the length and divide by 2, which gives you 0.575 times the force that's pulling down, which is the mass, 1.4 times 9.8, or 13.72, and multiply that by the sine of the angle between radius and force, which is 238. You do out that calculation and it gives you a nice negative 6.69, which is correct because it's moving this way, which is by convention a negative torque. Number 2, you take a door and you're swinging it, so you get your radius, which is 0.82, times your force, which they give you as 14.6 newtons, and your sine of your angle, which, since it's pushed this way, you set up your little XY, goes kind of like that. Here's your force here. You swing from radius to force, which would be, how do you do that? You swing counterclockwise, so like that or something, and you end up with, how do you swing? You swing from radius to force and get a 310 degree angle. You multiply those all together and get negative 9.17, which again is correct because by sine convention that should be a negative torque. Number 3, it's basically RF sine theta plus RF sine theta. You have a 0.14 times 22, which is again your given force, times the sine of your angle between the two, which is 260, and add that whole term to the 0.11 times the force, which is given as 18 newtons, and then not given, but since it's coming straight up, you swing from radius to force and get sine of 90. You do that calculation out and end up with negative 3.033 plus 1.98. Add those two together to get negative 1.053, which again is right because since this is greater, you're going to have a leftward torque, and again that's going to be negative. So number 4, you're going to have, since it's stationary, it's going to be equal to 0. You're going to set it equal to 0. And you're going to have an RF sine theta and an RF sine theta, your first of which is localized at 0.68 meters with an 88 Newton force. And sine of the angle is going to give you sine of 90, which is 1. Add that to 0.24. And then, since you don't know the mass, and the force is going to be mass times gravity, you can solve for that later, so hold on. Times negative 1 because it's sine of 270. Because they're going to be, this is going to be perpendicular here, so it's going to be from radius to force is going to be 270. And again, this is going to be from radius to force is going to be 90. So when you're solving this out, basically you just have a negative, and then you do out this calculation and then divide by 0.24, then again divide by negative 1, and then divide by 9.8 because it's mass times gravity. So to get your mass alone, divide by 9.8, and you're going to end up with 25.44 kilograms. And in number 5, you have a 1 kilogram meter stick, and if it's balanced at the center, you can say that the net torque is going to be 0 on that. So basically what you end up with is a something like this with 0.2 kilograms coming down this way, So what it's going to be is 0.2 times 9.8, I believe, times 9.8. My calculator is freaking out on me. Hold on a sec. That's going to give you 1.96. Going to multiply RF sine theta. It's going to be, multiply that by 0.3, which is your radius, and you're going to end up with 0.588. But since it's again going to be torquing to the left, it's going to be negative, and you know that from your sine of 270, which is your, if you swing from radius to force again, that's going to be 270, so it's going to be negative 0.588. This fulcrum, and then when it's moved, basically you end up with the same thing. It's moved over kind of like that, but since it's you can localize it at 1, since that's to the right of it, it'll be torquing this way. It's going to be negative again. So the thing to do is, again, negative 1 times 0.15, which is the distance from 35 to 50 where the mass is localized, and that times 9.8, since your mass is 1 times 9.8 is just 9.8, and 0.15 times 9.8 and times negative 1 is going to give you a negative torque of 1.47, and that is quiz number 43.